Hello everyone and welcome to Clarity in Physics. Today we are going to talk about another fun topic in physics. It is all about the laws of motion. So without wasting our time, let's get started. Have you ever heard about the three laws of motion? Here is a quick history about the three laws. The laws of motion are the relationship between the forces acting on the body and the motion of the body. These laws were first formulated by an English physicist, Sir Isaac Newton. These three laws were published in his book Principia in 1687. Now that we know the history of the laws of motion, it has tackled them one by one. Newton's first law is known as the law of inertia. The law of inertia was first formulated by Galileo Galilei for horizontal motion of Earth and was later generalized by René Descartes. So what is inertia? Basically, it is an object's tendency to keep doing what it's doing. The first law is stated as an object in motion will remain in motion and an object at rest will remain at rest until and unless acted by an external force. And what does that mean? It means in order to change the way an object moves, a net force must be present. The most important thing to know about the first law is mass. You see, the more the object has mass, it would be harder to apply force to the object with more mass, and it will be hard to stop once it starts moving. To understand this, let us take an example. Let us say you have two balls of the same size but different masses, like a plastic ball and a Costco ball. Among the two balls, the Costco ball is going to be harder to move, and stop it has more inertia because it has more mass. Now on his second law, we are going to talk about the importance of the net force. Newton's second law talks about the changes that a force can produce on the motion of a body. It states that the time rate of change of momentum of a body is directly proportional in both magnitude and direction to the force imposed on it. That is, dp upon dt is directly proportional to F, where P is the momentum of a body and F is the force imposed on the body. On removing proportionality, we get a constant K whose value is equals to 1 in SI unit. Therefore, we get dp upon dt is equals to F. Let us say this is equation number 1. Now, we know that momentum P is equals to mass m into velocity v. So, from equation 1, we get dmv upon dt is equals to F. For a body whose mass m is constant, therefore, m will come out from the differentiation. Now, our equation become mdv upon dt is equals to F, and as we know, dv upon dt is equals to acceleration a, hence ma is equals to F, or we can say F is equals to ma. So the conclusion is, for a body whose mass m is constant, it can be written in the form of F is equals to ma, where F is the force imposed on it and a is the acceleration. Both are vector quantities. Now let us talk about when an object accelerates. When the forces are in balance, it means that the object is accelerating. The most common cause of an object to move is because of the gravitational force. When an object falls downward, it is accelerating downward at a rate of 9.81 meter per second square. In our formula, it is F is equals to ma. The force acting on the falling object is gravity, which means the formula becomes F is equals to mg, where g is the gravitational force. Among those forces, these forms tend to be present at all the times. These forces will be discussed through Newton's third law of motion. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the third law of action and reaction. What does it mean? It means that when you apply a force on something, it gives an equal amount of reaction force. Say you have a skateboard. Once you press your feet against the floor will have an equal amount of force to your feet. That is why you can move. That equal amount of force acting upon you is called as the normal force. The normal force is a force perpendicular to whatever surface your object is resting on. The normal force is unlike other forces, since this kind of force can change its magnitude. What does that mean? Let us say that you have a piece of paper and a coin. You hold the paper on the air and place a coin on it. The coin applies a force on the paper and the paper applies an equal amount of force. Now you add another coin on the top of the paper. The coins apply the force on the paper and the paper also applied force in the two coins, which means that the normal force is doubled, and then you keep on adding coins to the paper until such time there are too many coins which cause the paper to tear. That's what happens when a normal force cannot match the force pushing against it. And that's it. Did you enjoy our topic for today? I hope you certainly did. See you again next time for more interesting and fun topics only here.